What's up, boys and girls? Welcome back. Little quick 5-minute lesson reviewing the Pythagorean theorem. Okay, so hopefully you all know this. It's definitely one of the most important things that you've ever learned in math. It's very much the foundation of pre-calculus. They used to call pre-calculus trigonometry. It was just all about triangles, and it's very much still about triangles. So the Pythagorean theorem says in a right triangle, the hypotenuse squared is equal to the sum of the legs squared. So you can see that in this triangle, A and B are the legs. They form the right angle. C is the hypotenuse. I hope that's familiar to you. So let's just do a quick example and maybe even get a chance to review how to simplify radicals, because that's something that people get confused on. So here, if we wanted to find AB, we would say 3 squared plus 10 squared equals x squared. Let's label that an x so we know what we're finding. So it's going to be 9 plus 100 is x squared. So x squared is 109. Take the square root of both sides, and x is the square root of 109. Now, normally when we take the square root of numbers, there's 2 answers, but since this is geometry, we can't have a negative length, so we leave it like that. And then this radical is simplified. I think later on in the video, we'll probably get to one where we have to simplify the radical. If not, I'll review it here in just a second. Okay, so now we've got a little blurry one, but it's going to work just fine. And this is a 6, and this is an 8. And they want to find the missing side. So here we'll call this y. Notice now we're missing a leg, so our equation will look just a little bit different. Y squared plus 6 squared equals 8 squared. Okay. So y squared plus 36 is 64, excuse me. All right, so we're going to subtract 36 from both sides. And you get y squared is, let's see, 34 minus 6, 28. Okay. All right, so now take the square root of both sides and you get y is the square root of 28. Now, you might be taking your ACT and you have this very problem on there. And one of the choices will be that. And how about those two things are the same thing? This is equivalent to this. So how did I come up with that? Well, this is how this works. Square root of 28. You need to think about all the perfect square numbers. 4, 9, 16, 25, ... Do any of those numbers go into 28? Yes. 28 is 4 times 7. And what's the square root of 4? It's 2. So that's how you get to 2 radical 7. Don't forget how to simplify radicals. Okay, so when I was younger, I used to call this the Michael Jackson of right triangles, because in the 90s, Michael Jackson was without a doubt the most famous person in the world. Probably Michael Jackson, Michael Jordan, and maybe the President of the United States were probably the most famous people in the world at that time. And this triangle shows up everywhere. It will be on your ACT. It will be on your probably your AP exam. Like, it's just a very simple triangle, and it works. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. But you could also have it be 30, 40, 50. Go ahead and try that. If you do 30 squared plus 40 squared, you will get 50 squared. It could be 0.3, 0.4, and 0.5. You could try that if you want. That works. It could be 6, 8, 10. Try that. That works. So I want you to be aware of this, because seeing this can save you a lot of time on exams. So just beware. Okay, now the distance formula. You might be like, well, what are we doing the distance formula for? This is algebra. Well, it's all related. It's just math. So look, if you wanted to find the distance between 2, 6 and 5, 2, okay? You want to find the length of that segment. You can't count because it's diagonal, okay? So you might remember that distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So for this one, it's going to be the square root of 5 minus 2 squared plus 2 minus 6, 2 minus 6, 2 minus 6. Sorry. Squared. So what do you get for that? The square root of 3 squared plus negative 4 squared, square root of 9 plus 16. Oh, there it is. Square root of 25, just showing you all my work. It's 5. That distance is 5. But how could we have also done that? Well, we could have just used a little art. Uh-oh, what did I do wrong here? If you notice, I had plotted the points wrong, so now I'm back. And that makes sense because I wouldn't have gotten the right answer. Look, how long is this vertical line? We can just count now. We can count. It's just 4. Oh, well, that's what we got here. Okay. And how long is this horizontal line? Oh, it's just 3. And that's what we got for this. That's all the distance formula is. It's just Pythagorean theorem. And now you see there's your 3, 4, 5 triangle that we just mentioned in the previous screen. Okay, so quick little review of Pythag. The next video, we're going to go over revisiting SOHCAHTOA, and then we're going to get deep into some more maybe difficult problems that involve right triangles that are word problems, and then you'll take your first little quiz. You guys can probably do this whole thing in a day or two, but it's important that you start with mastery of these right triangles. Boom!